TA Tech Tip will cover the data analysis associated with validation kits.
All of these data sets were collected on a low-volume instrument. However, the fitting principles shown here can also be applied toward the standard volume instrument as well. The first set of data in the validation kit is the water into water. So this one we're looking at how does the baseline look? Are we just seeing the minimal amount of heat associated with these injections that is attributed to frictional heat as well as DT between syringe and cell? First step is to recreate the baseline so we don't include unnecessary noise. And now you can see we've cleaned up a few areas. Next step is to go to the area tab. We will need concentrations in both the syringe and cell. These are dummy concentrations and won't be used in the fitting, but they are necessary in order to proceed to the next tab, modeling. The appropriate model for the water into water is the blank constant. So we're going to load the model, but we're going to apply a little bit of smart fitting, meaning we saw all of the data, it was all exothermic. And we can also look on our baseline and see that the minimum value on the y-axis is around -5. So we'll change everything to exothermic with a minimum -5 and change our precision to 3, which will enable us to fit the data a little bit more quickly. So this I would consider a good fit for the water titration. The next I would go to the N-propanol into water. So this one we're evaluating the injection of that particular syringe as well as the burette apparatus. So again I can look at my baseline, see if I want to shorten any time increments. Go into the Create New Baseline. Go over to the Area tab. Again, these are dummy concentrations, but they won't be involved in the modeling. For the N-propanol into water, as I've already done here, mask the first data point, and the appropriate model is going to be the blank linear model. Select that model, and again, let's apply some smart fitting. So we can create a large range here with a minimum, and we'll give ourselves a little bit of leeway. And in the slope, we expect it to be anywhere between 3.3 plus or minus 1. So again, putting in some values here to do smart fitting, which will enable us to get a fit much more quickly. So the data's been fitted, and we probably would like to change the precision as we did with the water into water titration as well. Refit, and we're done with that. The last experiment in the validation kit is the acid into base, or the HCl and bicarbonate. So once again, we're going to look at the baseline, zooming in instead at a particular area, in this case through the inflection region, where we get a little bit more tailing on those peaks. So we could leave it as is, but we will bring this in a little bit, and we're going to zoom in on just this one peak to make sure that we've done an okay job with the baseline. And that looks fine. Undo zoom. Area tab. This is where concentrations as well as cell volumes are important. Next, go into modeling. So first thing, we mask that first data point. So first I want to do is zoom in on this area. These last few data points of this heat right here are the heat of dilution. And we're coming in around the same place where we did with the water, around -3, -4. So I'm going to load in two models. The first model is going to be the blank constant. That's going to take care of the background. The second model we'll load in is the independent or one-site model. And just like we did on the water into water, we can go ahead and constrain these values. Max being -1 and the min being -5. Independent, we know that we're expecting around 2 times 10 to the 6th for this value. So we can start to constrain this as well. Now we can go ahead and go through the fitting iteration, stop it, see how it fit. It definitely needs some more time, and we'll let it go through all by itself and come to the best fit by itself. I personally like to clean up my data after this. I take this blank constant value, -3.46. I'm going to delete that model and just enter that into the area subtract constant. And now we can refit. Data looks good. Everything fell within our expected. And we've gone through all 3 data sets for the validation kit.